This is our first chapter, chapter 1. Normally I spend only a few minutes on this in class, but it is an important chapter as it discusses the units that we'll use in the class and also the concept of significant figures. Now, we will use the international system for the most part. So as you know, the SI system, so meters, kilograms, second. And we know that a Newton, which is a derived unit, not a fundamental unit, is based on a kilogram meter per second squared. For the most part, kilograms and newtons and meters are all we'll use. We won't use seconds because we're not dealing with time in this class. We know that a Newton comes from the idea of F equals ma, where if we take 1 kilogram and accelerate it 1 meter per second, we get the equivalent of 1 Newton. So it's sometimes what you'll find in classes, instead of giving you a force in newtons, they may give you a mass in kilograms. And usually then that's treated as a force because as a gravitational force. However, we have to remember to multiply by gravity. And so anytime you see something that says 10 kilograms, 100 kilograms, or whatever, then that's your cue to multiply it by 9.81 meters per second squared and get that into newtons. So this is stuff you've seen in other classes, and I don't think we need to belabor it. We will also use US customary units, foot, pound, seconds. And you may recall that a slug is the true unit for mass. You can have a pound mass and a pound force. And we won't really use a slug per se in class. It turns out that whenever you're given a pound in this class, it's a pound force. So don't make the mistake, never multiply a pound by 32.2. That won't be correct. Just treat a pound as a force anytime you see it in this book. And again, that's only in this book. So that's system of units, things you should be familiar with. But and one thing about this class, we don't mix units. So I won't put meters and pounds in the same problem. I won't put kilograms and inches in another problem. So we'll stick to one or the other. The other thing is significant figures. And I know that in some classes, significant figures tend to be emphasized more than in others, but they are important. And I know that you may have heard differing things on significant figures, but for the most part, if we follow these simple rules that are laid out at the beginning of your textbook, then they'll be good for this course. Now, and I want to emphasize that this is for my course. Now, I'm not giving you any significant figure rules that don't work in general, but other instructors may have different criteria for you. Now, all the numbers that you're given have some error to them. So if we say that you have 500 newtons applied at point A, we don't know for a fact that's 500.000 newtons. We're assuming that there's somewhat of an estimate and that there is some error. Just like with any number, there's always error. And one of the things we don't really address in this class is the concept of error. We always give you numbers and they're treated as absolutes. But just keep that in the back of your head that oftentimes in real practice, you're not going to know the exact force to several decimal places. In fact, you may have several percentage error built in. So the significant figures allow us to kind of address this error in our final answer. And the rules are that we will use 3 significant figures for answers where the leading number is a 2 through a 9. And so what does that mean? If you have a number like, say, if my example here, 56.786 pounds, then you're going to write that as 56.8 pounds, of course, rounding up the 7 to an 8. And in that case, you just have the 3. If you have a number like 846,650, then write it in scientific notation, and using the proper scientific notation with only one number before the decimal, and then to the appropriate power. If you have a number that leads with a 1, you're going to use 4 significant figures. And I've had many questions about why this has to do with the fact that a 1 is smaller compared to a 2 through a 9, and so that extra significant figure is a bigger percentage of the overall number than if it was a later number. Now, but this is, again, just a rule. And if you follow it, then that's what I'm going to look for on my answers. And so just be consistent with that. And it's surprising each quarter I say this, and over the course of the quarter, 5 weeks in, people still aren't doing the correct number of significant figures. And it's not until I start taking points off do people really remember the rule. And I'd rather not do that, but if you turn in homework that has improper significant figures after the second assignment, then you will lose points. And you may ask, well, what's the big deal? And really, the reason I do this is not to be a stickler for this, but it's about details. And as an engineer, eventually you're going to graduate, get the big six-figure income, and you're maybe working on thing that has the potential to affect human life. You might design something that if it fails, someone might die or get hurt. And so paying attention to details is a very important part of being an engineer. It's something that you should practice in your classes and something that you should keep in the back of your head at all times. All right. So that's the two rules, and just practice them, use them, and you should be fine. If you're in doubt, use scientific notation. And when you're working a problem, don't worry about significant figures till you get to the end. It's okay to carry a few extra numbers while you're in the intermediary steps. So if you want to leave numbers on your calculator, go ahead. I'm not going to look at significant figures until you get to the final answer. Then I'll look for what you have. But before that, you can keep as many as you want. That within practicality. Okay, well, that is very quickly what chapter 1 is about. So units and significant figures. If you have any questions, review the text or send me an email. So next lecture, we'll begin with chapter 2, and we'll start talking about forces. Thank you.